Hello, this is going to be a bit of an impromptu video in response to one I just watched on Miles Davis' channel. He's having a bit of a back and forth with Gleam, and they're discussing whether or not various hills or mountains or whatever they are over there are higher or lower than Hopeton Monument. So the information that Miles provided are basically these values here. Traprain Law has a height of 221 meters. Hopeton Monument has a height of 210 meters with a distance of 8.2 kilometers away. Ben Lomond is 974 meters high with a distance of 125 kilometers. Ben Narnain is 927 meters and 135 kilometers. And Benim is 1,011 meters with a distance of 137 kilometers. So the way I approach this, I'm using the property of the distance along the surface of the Earth to compute the radians. And the way you do that is the angle in radians is going to be the distance between the observer and the object divided by the distance between the object and the center of the Earth. If I turn that around, then the radians should be the arctangent of the distance between the observer and the object divided by the distance between the object and the center of the Earth. And then so from there, I just converted radians back to degrees. So the first thing I did was I wanted to convert the height of each observer or object from the center of the Earth. And I did that by adding the height to the Earth's radius. And the Earth's radius here is represented in meters. So this is going to be 210 plus the Earth's radius. This one is going to be 974 plus the Earth's radius, and so on and so forth. I calculated the angle from Traprain Law by taking the height from the center of the Earth for that object and the distance from Traprain Law to that object, which I multiplied by 1,000 as my parameters to the arctan function. Now I'm using arctan2 because that will preserve the sign, whether the angle is positive or negative. And then I just convert that to degrees, and these are all of the degrees. That means that would mean that you would travel 0.7374 degrees from Traprain Law around the Earth to Hopeton Monument. And 1/360th of the Earth's entire circumference would equal roughly the distance between Traprain Law and Ben Lomond, for example. So now we have this angle calculated. So the next thing I wanted to calculate was how many meters below Traprain Law that particular observation point would be if you drew a triangle from the center of the Earth to the observation point, then from the observation point to the observer, and then back down to the center of the Earth, where the angle from the observation point to the observer and to the center of the Earth is a 90-degree angle. And I calculated that by using the cosine of the angle that I calculated earlier. which equals the base divided by the hypotenuse. And I know the hypotenuse, and I'm trying to calculate the base. So I'm trying to calculate this value here, which happens to be the cosine of the angle times the hypotenuse. And meters below Traprane law is going to be the height of Traprane law minus the base that I just calculated. And that is going to be this formula here. So it's the cosine of this cell converted to radians multiplied by the height of the object or observation point in meters. And then I subtract that value from the height from the center, from the Earth's center. And I did that for all of them. This means that the angle to each observation point is the arctangent of the elevation drop, which is this, divided by the distance of the object from the observer. So I'm converting to degrees. The arctan2 function C6, which is the distance in kilometers, times 1,000 to get me meters, and meters below Traprane law times -1, because this was Traprane law minus this angle. So that happened to be, this should have been negative, and I would not have to multiply by -1. But that means that Traprane law at 221 meters and Houghton monument at 210 meters means that it's 0.1137 degrees below horizontal eye level. So this is going to be a minus, this will be a minus 0.11 degrees. And then I calculated the same for Ben Lomond, Ben Narnain, and Ben Eam. The next thing I did was I wanted to calculate what would it be like on a flat Earth. So for a flat Earth, it's very similar, but since Ben Lomond, for example, is 900 meters above sea level and Traprane law is 221 meters, this will be the difference in the height between the observer and the object to give us this value, divided by the distance between the object and the observer. And then if we take the arctan function of that, we get the angle here. And so I did something similar here. This one is going to be 8.2 kilometers times 1,000 to give us meters, and Houghton monument minus Traprane law gives us an angle of -0.07 degrees. Ben Lomond is a very similar formula. It gives us a positive angle of 0.345 degrees, which means that Ben Lomond would have to appear above Traprane law. And same thing with Ben Narnain and Ben Eam. So that is how I did the math to confirm Miles' observation that this is only possible on a globe Earth. Thanks for watching, and hopefully I'll see you again in another video soon enough. Bye for now.